Now let's start a new function topic called parabolas. Before talking about parabolas, let's just first review what a straight line is. So what is a line? Well, a line is a linear relationship between x and y. They're both first degree. Y equal kx plus b. So if here is a second degree, that would be wrong. It's not a straight line. And let's say a special case. 1k is 0 and b is 1. So y equals 1. It means a horizontal line on the x and y coordinate system. And another special case is 1k is 1 and b is 0. It will be y equal x. So it's basically like this. Its x coordinate equals its y coordinate. It's a special line. So any relationship where x and y are first degree linear is called a straight line. So what is not a line? For example, given you a function like a reciprocal function y equal 1 over x, or a quadratic x y equal x squared, or a cubic y equal x cubed, or any combinations of these, none of these are lines. Their graphs look quite different, and we will study them independently later. For now, just remember, if y and x have a linear relationship, y equal kx plus b, that's a line. Otherwise, it's not. And now let's take a quick look at the most basic parabola, y equal x squared. How do we draw this graph? We start from its equation, y equal x squared. What does it actually mean? It means that for any y and x, the coordinates satisfy this relationship. And let's just try plug in some of the values for x. For example, if x is 0, y is 0 as well, and x is 1, so y is 1. And 1x is 2, y equal to squared, which is 4, and y-axis is 3, y is 3 squared, which is 9. And now let's just try to plot those points on the coordinate system. So let's call the first point point A, and point B, and point C, 2, 4, and point D, 3, 9. I need to extend the coordinate system further. Oh, let's make it here. Okay, so A, B, C, D, we have 4 points here. So is this function linear? Does it look like a straight line? And how do I connect them? Well, here's a tip. You can try to connect 2 points together and you see C and D doesn't actually lie on it. So it's not a straight line. Similarly, if you try to connect B and C, we find actually D is not on it. Oh, I need to move the upper because it's 3, 9. And when I connect C and D, we find other points are not on it as well. So the most intuitive way to say it, it's not a straight line. So what it will be looking like? And with a computer, or you can even do it by your hand. Let's plug in more points. Say 1x equals 0.5, 1.5, 2.5, and 0.2, 0.3. When I'm using computer to plot more points on it, it's quite clear that it looks like a parabola. And conversely, if I insert more points, let's say 1x is -1 or -2 or -3, it also looks the same. So with more points on this graph, it's a parabola. So with the help of computers or more detailed plotting, we can insert more points by making it more clear, and it will be looking like this, a parabola. And now, what are the features of parabola? The simplest one, y equal x squared. Y equal x squared passes through the origin. And later we will study more complex forms like y equal x plus -1 squared plus 2, or y equals 3x squared minus 4x plus 5. And how do we draw these functions? Well, that's a very important idea called translation or shifting functions. You understand the very basic paragraph, understand the very basic parabolas, y equal x squared, and then you just need to do simple translation, dilation, rotation, and you can get other shapes of the parabolas. So that will be way much easier. Let's just take a simple example. Say y equal x squared. So it will be looking like this, just like we did before. And then y equal x squared plus 1. So it means to translate the original function up for 1 unit. So it will be looking like this. And similarly, y equal x squared minus 2, it will be to shift it 2 units downwards. And for horizontal shift, y equal x minus 1 squared, so it means to shift it to the right for 1 unit. So it will be looking like this. And y equal x plus 1 squared, it will be shift of it for 1 unit left. So we often summarize this as left. Oh, here is quite tricky. You can just remember it. And for deduction, I will discuss about later. So for right or left shift, it's inside the parentheses. And plus means right. No, I'm sorry. Plus means left. And minus means right. So if you have a clue, say y equal x squared, so it's a very fundamental shape of parabola, and given you y equal x minus 1 squared, so it's minus, so minus corresponds to right, so it means translate the function 1 unit right. It will be looking like this. And you should know, translation means you make every point of the same unit of translation. So its original vertex, let's say 0, 0, will be transformed into 0, 1. And this point 1, 1 will be translated 1 unit right, and it will be 2, 1. And for this point, minus 1, 1, it will be transformed into 0, 1. So every single point will be translated 1 unit right. And if I connected them together, it would be looking like this. And for plus is right. So y equal x plus 2 squared, that means to translate it 2 units left. And drawing this function will be looking like this. And its vertex will be minus 2, 0. So just remember this trick. And for going downwards or upwards, we also have another clue, and you can just write it down. So up or downshift translation outside the parentheses. They normally occur there, outside the parentheses. So for y equal x squared plus 2, it means from the original function y equal x squared to move it 2 units upward. So it will be looking like this. And for y equal x minus 3 squared plus 4, let's just do a simple one, plus 4, it means to move it 2 units more, or just from origin, move 4 units upward. And now let's try to do a complicated one. Y equal x plus 3 squared minus 4. Let's just try to make it original one, y equal x squared. So it's a basic parabola. And then you need to move it 3 units left and 4 units down. So this will be the graph. So it's quite simple. We just need to move the original shape. And by doing this, we can basically draw every parabola. But before that, I think we need to talk about something more complicated, like how to do dilation or how to do dilation on the x and y horizontally. But I think this is enough for now. We also need another important change, vertical stretch or compression, which is called dilation. For example, y equal 2x squared. What's the relationship between it and y equal x squared? It's not simply translation, it's more about dilation. So let's say y equal x squared. So if you draw them, when x is 0, 1, 2, 3, they all correspond to the value of 0 squared, 1 squared, 2 squared, 3 squared, which is independently 0, 1, 4, 9. But if we insert another function here, y equal 2x squared. So when x is 0, it's 0. And later it will be 2, 8, 19. And if we draw them in the same graph, so when I'm trying to plot those points, this is called point A, point B, point C, A, B, C. And for the second equation, let's call them D, E, F. So you basically double their y value. So the graph will be looking like this. When you do the fundamental paragraph, it's looking like this. And another parabola, it just looks like you're narrowing it. So this function is narrowed by the parabola, or just make it smaller. And for y equal x squared, but with a minus in front of it, you can see, so the corresponding value is 0, minus 1, minus 2, minus 9, or minus 4, minus 9. And when you plot them on the graph, it looks like that I have flipped them. And you can think of this as multiplying this minus factor here to stretch it in the direction of minus 1. And now we have all the ingredients. You have the basic parabola, y equal x squared, and if you want to shift it left or right, you can just plus a constant here. And if you want to translate up, down, or upwards or downwards, you can just plus another constant here. And if you're trying to stretch it along the y-axis, you can just plus another constant here. Or let me just change the sequences here. So it's A, B, and C, and that's normally how we arrange them. So it's quite simple for you to draw a parabola. So y equal x squared will be looking like this, and you can try to do this one, x minus 1 squared times 2 plus 3. So first, you move it right of 1 unit, and move it up for 3 units, and then you're doubling it, you're stretching it 2 times on the y-axis. And that's how you draw it, well, on a rough way. If you want to be more specific, you want to be more precise, you can insert more values in it and let the computers do. And what I just wrote before is a vertex form of a parabola. I will see that later. From this function, let's say y equal x minus 1 squared plus 3, you can clearly read that its vertex will be 1, 3. If you don't have a capacity, it's okay. I'm just listing it here. And we have a more general form, y equal ax squared plus bx plus c. This is called its general form. So you can understand this constant by this. A basically controls the direction and steepness of the parabola. So it means how many times you're trying to stretch it, how many times you're trying to do the dilation. And B affects the horizontal position, and C affects the vertical position. Well, if you apply them there, it will be totally accurate. But if you're trying to understand ABC like in this way, it's also fine. It might be some mistakes, but it's also fine. You understand A as a dilation, B as a horizontal shift, and C as a vertical shift. So next time, you can understand the parabola like this. So it has a vertex 0, 0. And then you are moving this this vertex. So to summarize, why is y equal x squared a parabola? Well, the most obvious reason is because it's not a straight line. By plotting 3 more points, we're aware of that by connecting 2 points, the other points won't lie on it, so it's not a straight line. And by plotting more points, even by hand or by computer, we can see clearly that it's a curved shape, and it's called parabola. Because it really looks like a parabola when you're trying to throw things away. And we use plotting points to understand how it looks, and we study shifting and scaling, reflecting, to get all kinds of parabolas. And finally, we reach the final form of y equal ax squared plus bx plus c, or the vertex form, y equals ax minus b squared plus c. And next, I think we might need to learn more. How to tell if a parabola opens upward or downward, and how to find its vertex, axis of symmetry, and intercepts, how to sketch it precisely from its equation. And I think today is a lot for this lesson. If anything is unclear, it might help to rewatch the video or review the examples. We will explore more exciting things about the parabolas later. And if you feel this video interesting, just feel free to give it a like and share it to anyone you think might be helpful of. I will be very appreciative. So see you next class.